Hello my dear students, welcome to Fluid Mechanics lecture series. I am your Sumam. Today we are going to discuss about capillarity. It is a consequence of surface tension. Basically both surface tension and capillarity depends upon the atomic structure of fluid, and it also different from different fluids. So the major forces that is governing this phenomena, cohesive forces and adhesive forces. So if the cohesive force is more, we can see a capillary fall, or if the adhesive force is more, we can see a capillary rise. So this is the reason why the kerosene that is rises through a cotton wick which we inserted in the reservoir of kerosene in a kerosene lamp. This phenomena is partially responsible for the rise of water to the top of the trees. Let us examine this capillary effect. So this effect is due to the cohesive force and adhesive force. Now consider a tube which we inserted in water. So you can see a capillary rise. That is just because this adhesive force is more than the cohesive forces. Whereas in the case of mercury, you can see a capillary depression, because in mercury cohesive force is more compared to the adhesive forces. So that is why you can see that level of this mercury that is curved down. Whereas here the level of water that is rising up. That means this edge is rising up. So that means this type of fluids we can call as wetting fluids. In wetting fluids, adhesive force is more compared to the cohesive forces. Whereas mercury, that is a non-wetting fluid. So if you are dropping mercury on a glass plate, you can see that due to the surface tension, it will behave like a spherical ball. It occupies a spherical shape because for a given volume, spherical shape has the minimum surface area. Now let us discuss about the capillary effect. Capillary effect means a rise or fall of the liquid. So surface tension force act along the tangent towards the solid surface. So here also surface tension force that is acting along the tangent, which makes an angle phi with this boundary. So the magnitude of the capillary effect that can be determined by the angle of contact. So this is the angle of contact. The angle that tangent to the liquid surface makes with the solid surface at the point of contact, that is called this wetting angle. Since the water wet the boundary, we can call this is a wetting fluid. Wetting fluid means adhesive force is more than the cohesive force. So if you are inserting a rod in water and if you are taking out of this rod, the rod is wetted with water. Or we can classify the liquid as wetting or non-wetting based on the value of this contact angle. So if phi value that is less than 90 degree, then liquid wet the surface. Whereas this angle of contact which is more than 90 degree, it is called a non-wetting fluid. So mercury is a non-wetting fluid, whereas water is a wetting fluid. The strength of capillary effect is quantified by the wetting angle phi. The phenomena of rise or fall of the liquid in the capillary tube or in the small tube we are inserted, that is called capillary effect. Capillary effect can be determined by considering a tube in the water. So you can see two tubes here. So one tube is of higher diameter compared to the other one. So when the diameter of the tube increases, capillary rise that is also small. So here the fluid is water. So the capillary rise that is occurring for the small diameter tube is more compared to the large diameter tube. And phi is the contact angle. The magnitude of the capillary rise in the capillary tube can be determined by balancing this weight of the column against the surface tension force. Weight of the column that is acting downward, whereas surface tension force or the component of surface tension force that is acting upward along the boundary. So weight of the column that is equal to mg, that is equal to specific weight multiplied with the volume. So rho g indicates the specific weight and multiplied with the volume. So pi r square h will be the volume of this water. That is component of the surface tension force that is acting in the upward direction. So the weight that is acting downward is getting balanced by this component of the surface tension force which is acting upward. Component of the surface tension force acting on the periphery of the liquid column, that is equal to 2 pi r, that is the wetted perimeter. So 2 pi r into sigma cos phi, that is the component of the surface tension force opposite to the weight. So if you are balancing these two, H equal to 2 sigma cos phi divided by R into rho g. So H means is the capillary rise, R is the radius of this tube, and rho g is the specific weight. If the water is very clean, that means for pure water and a clean glass tube, this phi equal to 0. That means phi equal to 0 means cos 0, that is equal to 1, or H equal to 2 sigma by R into rho g. Suppose this liquid is different. So what we can do, the specific weight of the water, that has to be replaced. So that means that specific gravity of the liquid multiplied with the rho g, that will give you the specific weight. That we have learned earlier, that the specific weight of any substance equal to the specific gravity of that substance multiplied with the specific weight of water. So rho g means it is the specific weight of water. So rho g is multiplied with S will give you the specific weight of the corresponding liquid. So H can be modified as 2 sigma cos phi divided by R into S into specific weight. Capillary effect is negligible if the diameter of the tube that is higher than 1 centimeter. So that means whenever we are having engineering applications and we are dealing with the small tubes, the diameter of the tube that is used, its size should be higher than 1 centimeter. For example, if you are using piezometer for measuring the pressure. So in order to eliminate the capillary effect, what we have to do is the tube size should be higher than 1 centimeter. Capillary effect can be determined by solving the problem. Capillary effect of the fluid can be determined by dropping the tube in the two liquids. One is water and other is mercury. So here in this problem, so capillary effect in mm to be determined, and glass tube diameter is given as 4 mm. The case 1 is water and the case 2 is mercury. Before doing the problem, what we have to do is we have to copy down all data. There are two liquids are available. You should know the specific gravity of the liquids. For water, the specific gravity equal to 1. And for mercury, the specific gravity equal to 13.6. So all units that should be first of all converted into the relevant unit. Then next part is you have to get the value of capillary rise for water as well as for the mercury. So for the water, if you are directly applying the equation is H equal to 2 sigma cos phi by R into R means radius into S means specific gravity and rho g means that is specific weight. So specific weight of water, that is equal to 9810 Newton per meters cube. So in the case of water, specific gravity equal to 1. In the first case, we can determine H by substituting the values in this equation. So H equal to 7.51 mm. And for mercury, the specific gravity equal to 13.6 and angle of contact is 130 degree. So if you are substituting these values in this equation, you will get H value as minus 2.46 mm. So minus value which indicates that it is not capillary rise but it is capillary fault. So this can also ensure that because here the angle of phi that is higher than 90 degree. So that means mercury is a non-wetting fluid. So that means instead of capillary rise, you will get a capillary fall. So capillary fall for the mercury equal to minus 2.46 mm. Capillary effect can also be determined when we are keeping water between the two parallel plates. Since plates are given to be very clean, the phi value that is equal to 0. Now consider unit length of plate. So here surface tension of water is given as Newton per meter and the spacing is given as 1 mm. So what we have to do, again we have to start from basic principle, that is component of the surface tension force that is balanced by the weight of this liquid column. So weight of the liquid column equal to this space multiplied with H value and we consider the unit length. So that will give you the volume multiplied with the specific weight will give you, that means weight of the water column between the two plates. So this is getting balanced by vertical component of the surface tension force. So here contact angle, that is phi value that is equal to 0. So that means here this term that is cos 0 that is equal to 1. So it is 2 sigma equal to specific weight multiplied with d, that should be converted into meter, into h, that is to be determined, and here considering unit length, so that is multiplied with 1. Here h value equal to 14.9 mm. So this is the capillary rise in this case. In this class, we had discussed different type of problems that we can experience in the field due to surface tension and capillary effect. So for the time being, it is enough. Thank you.